Okay, so grade 10s. We're on page 329. So last week we started talking about factoring. Then we kind of had a break. We started work. It's been a little disjointed. My apologies. It's kind of what it is. Today we're going to talk about two things, actually two different topics. The first, incredibly easy. The second, fairly difficult. Okay, so we'll ease in. So remember, our first lesson we talked about the greatest common factor. So if you had 4x plus 8, my GCF here is 4. Correct? We remember this, you don't have to write this down. So when I factor this guy, I can factor out a 4, leaving me with an x and a 2. Do we all remember this? Vaguely, Paisley, put away the book. I love reading as well, but right now not reading. We remember how to do this? Yeah, that's familiar. You all could factor that question. Quentin, why is there nothing in front of you? Get a piece of paper. Get a blank piece of paper to at least follow along. Okay, so today what we're going to do is we're going to talk about factoring by grouping. So class example 1 has a couple of examples here. So this first one, it says 4x times x plus 7 and x minus 3 times x plus 7. So what's common on this one is that whole expression of x plus 7. So when we factor, or when we remove that or divide it out, we literally end up dividing out that whole term. So I can factor out that x plus 7, and I'm left with 4x and that minus 3. Does that make sense there? 329. This second example, we have 3 minus 2y and a 3 minus 2y. So that's common in both of them. So in some ways, when we're using like polynomials, this is a little bit of review from last week. This is what it's building on though. Some ways polynomials are a little bit easier to factor than just two numbers because visually it's right there and clearly apparent. So in this one, we factor out our 3 and minus 2y, and then I'm left with the 7 plus 2y. This last one, 4a plus 1, is common on both. But the second term, I won't box that. The second term is literally the only thing there. So when I factor it out, we have to leave a plus 1 as our like placeholder, so that when, if I was to multiply it, this whole term has something to be multiplied by to reappear. So when it's the whole term itself, you leave that plus 1. If that doesn't make sense, you need to speak up right now. We're good? Okay, so the next 4. So the next questions are similar to this. It's going to, oh, my screen froze. It's going to add to a little bit of the difficulty here. We're not going to do all of these. A, I think, should be fairly easy. Let's still do it. So A, 3x minus 2, common on both. What's different with A? So a question like this, I would just say factor, and that would be it. You always need to leave your answer in simplest form. Just like with fractions, you always reduce your fractions. I shouldn't have to give you those prompts. So in this question, this is what it's getting at because they specified simplest form, and that's why they set, this question is why they say that. So I factor out my 3y plus 2. My first part is left with 5y plus 1. The second one is 4y. Well, I can combine my y's. They're in the same set of brackets, so if I have 5y's here and 4y's here, that gives me 9y's plus 1. You have to do that. You are expected to always leave it in simplest form. Sometimes we forget because it just seems like we get in our routine of doing one step kind of thing, and then all of a sudden you forget to follow through. I'm going to skip B. I think you guys can manage B. On C, questions like this are going to come up often, and this is the sort of thing we tend to forget by the end of the unit. So in our first unit, we all kind of forgot what a degree was and how to calculate the degree, right? Pretty simple, but you lose it. This next piece that I'm going to cover in C is something you're likely to forget. So this one reads, I have x minus 5 on my first piece. So close to it is 5 minus x. So when you have something that's so similar, you can take a negative out, or you factor out a negative, and then it'll be the same. So whenever you see you're like, oh, that's so close to being able to do it, likely we can slightly tweak it to make it to be able to do it. So our first line, I'm just going to rewrite this first piece. It doesn't matter which one you do. Generally speaking, it's always like x minus something, x plus something, right? Or variable first. And so I like keeping it like that. So what you do is you're going to change your signs. We do that by factoring out a negative 1. So when we do that, and I'll do this in a different color to maybe emphasize it, this is going to become minus 5, and then negative 5 plus x. If I was to take this, you don't have to, like you could combine steps here. That would be totally fine with me. I'm just going to reorder this because that's then a positive x minus 5. Well, now with that little tweak, I have the same term in both that I can then factor out. By factoring out that negative and changing things, it allows me to get the same term on both that you can factor out. Have I overall changed the value of it? No, because in both of these, so like in the typed line of the question in my first line, 5 times 5 is 25. Negative 5 times negative 5 is still 25. So my value has not changed. The appearance has, but that then allows me to factor this properly. So then I can factor out that x minus 5, and I'm left with 2x minus 5. So that change in the sign ends up being a big deal, but it's a hard thing to remember to do a lot of the time. How is that? Is that okay? Okay, next questions. Oh, sorry, go ahead, Claire. Right now, yeah. There's more to it that will come, but yeah, pretty much. On this next one, similar idea, x minus 3, and then it's 3 minus x. First thought should be like, oh man, those are so similar, if only they were the same. Well, let's make them the same. So this one's going to become, so I'm just rewriting this first piece. And then we're going to switch our signs. So this is going to become a plus 4 minus 3 plus x. And again, you could skip this next step or do this all in one, totally personal preference. I'm going to rewrite it though. So plus 4 x minus 3, all I did was rearrange. So we're switching the signs by factoring out that negative 1. So now I can fully factor out that x minus 3 from both terms. I'm left with 20x plus 4. So this is just taking that greatest common factor, which we did in lesson 1, and like taking it to the next level. Continuation. The new topic for today is this next piece, which is factoring by grouping. We're going to come across in this unit a lot of different ways to factor a lot of different questions. You have to remember at the end of the day, I'm teaching you certain skills. So I'm going to give you questions to use those skills on. We will use factoring by grouping whenever there's 4 terms. Most of the time, like 90% of the time, there's going to be 3 terms. So you won't use factoring by grouping. As soon as there's 4 terms, that's your prompt to use factoring by grouping. This is a really big thing. I would put like a big star on the side. This is something that we are likely to forget by the time we get to the end of this unit. So what this means, on this first example here, I have 4 terms set up here. Could you combine the 3x and 6x together to make 9x? Totally. If you do that, though, it becomes infactorable or not factorable. We give you 4 terms together like this to prompt you to do factoring by grouping. Okay, so whenever there's 4 terms, your first thought should be factoring by grouping. Okay, so let's go through it. When we factor by grouping, you split them in half. You should notice, because I'm giving you questions that you can do this on, they can like match up in pairs. The first two will have a GCF and the second two have a GCF. What is common in the first two? X, lovely. Leaving me with an X and a 3. In the second two, what's my GCF? 6, so I can factor out a positive 6, leaves me with X plus 3. You will always, because I'm giving you questions you can solve, right? We're like making this work for you. Once you do this step, you should see you're always going to have 2 terms that you then could take it another step and further factor. So now I can factor out that X plus 3, and I'm left with an X and a 6. We give you these questions very nice. We design these questions to work for you. Once in a while, we will give you a question that you cannot factor to keep you on your toes. Okay, let's do this a couple more times. So in this next one, first 2 match up, second 2 will match up. Once in a while, we will reorder them so they're not just laid out so pretty for you once it gets a little more complicated. So in my first 2, what's the GCF here? 2x. You can also take an x out. So first term, I'm left with 4x minus 1. Now 1 is a placeholder. Second set, I can factor out a 3. Oh, look, I'm left with 4x minus 1 again. That's your check to make sure that you've taken out actually your greatest common factor. Because if you don't take out your greatest common factor, they're not going to match up lovely for you. And that's kind of a prompt that you've probably made a mistake. Okay, try C on your own. So on this one, first 2, greatest common factor, 4a. Could you have taken out just a 2? Yes, but then they won't match up beautifully after for you. So then I'm left with the 2a minus 1. Second one, this one you have to think a little bit more. I want to end up, and this is really important for you to think this, I want to end up with 2a minus 1. So that's really important that we want these 2 pieces to match. So in order to make sure I get that minus 1, I'm going to actually take out a negative 5. If I take out a negative 5, I then get the terms that I want. So then that makes my 2a positive, which is what I needed for it to match this 2a over here, and I get my minus 1. When I multiply back in my negative 5, it brings me back to the original, right? That's your check. But you have to make sure they match up. So now I can factor out 2a minus 1 from both parts, and I get 4a minus 5. How is that? Make sense? Is that okay? You guys are so tired, hey? Yeah. That's rough. Okay, let's look at F. That will be our last one. F, when we look at it, if I look at my first 2 terms, there's nothing common. Can I reorder this one to find something common? Yes, yes, you guys can do this. If I rewrote it so it was 5x squared, and if I moved this guy over, minus 15xy squared, and I rewrote my other 2 terms, is there something common between the first 2 now? Yep, and now there's something common between my second 2. So sometimes you might have to reorder. So on my first term, I now can factor out a 5x, leaving me with x minus 3y squared. So now we have to pause and think again. I want, at the end of the day, for my next set of brackets, to have this same thing, right? I want this in the end. I have a minus 6x here, and that has to become x. So I'm going to factor out then a -6. So -6 times x, that's good, that works out. -6 times -3 gives us the +18. So sometimes on questions like this, you really have to think about like integers. You have to think about like the final question, what you're actually wanting. Like there's a lot of little pieces at play. At the end of the day, we're just multiplying small numbers together. So the actual multiplication isn't difficult, but there's a lot of things you have to think about and keep in mind. And that's what makes this really hard. A question like this is like a level 3-4. Okay, so then my final step on this one, I'm going to actually finish factoring it. So x minus 3y squared is my greatest common factor. And then I get 5x minus 6. That question there is about as difficult as the factoring by grouping will get. There's other pieces to this unit where like 5, 6s and stuff will come from. We haven't gotten that far yet, but that's as difficult as factoring by grouping can get. How is that? Does that question make sense there? So in that one, it's as difficult as it can get because we have to reorder it and you had to remember to take out that negative. Okay, we're going to move on to another part that's about fractions. Turn the page. Fractions. So this won't come up a lot in our grade, but I want to expose this to you for next year. We will, because we're going to cover it, like it's totally fair game for your test, but it's especially helpful for grade 11 and 12. So fractions can come into play. You have to remember with fractions, I think this stuff, because we're going to give you nice fractions, is easiest to think of pictures to almost figure out the answers here, but there's a few different ways, so I'll troubleshoot them with you. So we're still talking greatest common factor here. Our greatest common factor is simply going to be a fraction. Remember, I just want to backtrack a little bit. So if I gave you 10x minus 5, my GCF is 5 here, right? In order to come up with my factored form, really, I'm dividing each one of these by 5. So then I'd be left with 2x minus 1. We remember this? This is okay? So coming back to the fractions, we're doing that similar idea, but now it's just fractions, so it's scarier. Doesn't need to be, but fractions are a little intimidating. So in this first one, they tell us our greatest common factor here is going to be 1/3 of x. We know in our brackets that there's going to be something else in there. How can we figure it out? Well, let's start simple. In order for 1/3 x, when I like multiply back in to become 1/3 x squared, I'm going to have an x here. On this second term, we already factored our x out, so we know we're just going to have something here. First term, we factored out the 1/3, so it's only an x. Cool. How many 1/3s are in 4? 12. So 2 ways you can do this. Literally, you can think of it as I have 4 chocolate bars. Do this in your head. Do not draw this out. But if I split them into thirds, how many 1/3 sections are there? 12. Or you could do it as division. 4 divided by 1/3. Do you guys remember how to divide fractions? We multiply by the reciprocal. So then 4 times 3 gives me 12. So the answer here is going to be x plus 12. Figuring out that 12 is the trickier piece. Okay, let's try B. So they tell us on B, 1/4 is our greatest common factor. So my first term, I'm left with an A. How many quarters are in 4? 16. Good. That one's easier, right? We're thinking about money. How many quarters are in $4? 16. Cool. Okay, let's try C. See, they switched up the order on us. So 2/3 was my final term, was my constant. We're factoring out 2/3. My first term is going to be something x. Last term is going to be a 1 because we factored out 2/3 from 2/3. So now we need to figure out how many 2/3 are in 6. This one, drawing pictures, is a little bit harder. So I would just do your division here. So in this one, so we're going to do 6 divided by 2/3. So that's 6 times 3/2, 18/2, 9. So we get 9x. If you want to draw out 6 chocolate bars, split them all into thirds, you would then combine how many pairs do you have, because it said 2/3. So how many pairs of 2 do you have? Just gets a little bit more complicated. I'll go through D, but D's more difficult than we probably would give you because there's 2 fractions here. They're telling us our greatest common factor is a quarter. The reason for that is there's quarters in half and there's quarters in 3/4. How many quarters are in a half? 2. Good. Think of like money again. How many quarters are in 50 cents? So I'd be left with 2a's here. Sorry, 2a squared. How many quarters are in 3/4? So then I'm left with 3b squared. Okay. So this next one, we're still filling in the blanks. They're prompting you here. This one I think is a little bit easier. This first one, 1/6, is just, sorry, 1/6a is our GCF. We're factoring out our fraction, basically. If you were to multiply it back in, we go back to our original. On B, couple pieces to think about here. Before we deal with our fraction, pi and r is common in both. So I'm going to have a pi and r in my GCF. Between a half and 2, there's halves in both of those, so I can factor out my 1/2. There are 4 halves in 2. That's where this came from. Okay, let's look at this next one. Our GCF here is going to be 2/5. Again, this one's a little bit trickier. So 4, I won't go through it all, but 4 divided by 2/5 gave us the 10. That's where this one came from. 2 divided by 2/5 is going to be 2 times 5/2. Our 2's cancel, so this is going to be 5x. 2/5 divided by 2/5 is just 1. Okay, I want you to try class example 6 on your own. Try A and B on your own. Let's see how you do, and then we're done. So these ones are tricky. Okay, let's go over these. So in the first one, A is common in both. There are quarters in 2, so I can factor out 1/4 in both of these. So 1/4 A can be factored out. In $2, we have 8 quarters. So this is going to be an 8. In the second term, we literally factored out the quarter, so that's nice. Out of A squared, I factor out it. Sorry, out of A cubed, I factor out an A, so I'm left with A squared. Your check, like if you're needing to do this or you want to do this, Your check is doing your multiplication. So when I multiply this back in, I'm going to get 8 over 4a, which, sorry, that's just equal to 2a. 8 divided by 4 is 2. 1/4 a times a squared gives me back 1/4 a cubed. So actually doing that multiplication is going to be your check to make sure you got it right or wrong. Okay, this next one's a little bit trickier to identify your GCF. Looking at our smallest number is a sixth. So there is sixths in a third, but there's not thirds in 1/6. So 1/6 is going to be your GCF. Remember, there's a whole out front of that x cubed. So in this one, I'm going to factor out 1/6 x. On my first term, my x cubed, I factored out an x, so there's only x squared left. In order to return back to a whole, this has to become 6, because 1 over 6 times 6 gives me 6 over 6, which is equal to our 1. 1/3, you were cutting up a pizza, and you cut it into thirds first, giant slices, and you cut it again. Each third is going to split into 2 pieces. X hangs out. My last term literally took that whole thing out, so it's just a -1. So there's a lot of different ways you can kind of visualize this as we go through it. These questions are tricky, really tricky. There's going to be 1 on your test. With fractions is what I mean. Okay, so these are practice questions. I'm just going to put spaces in here. There are, I think I gave you a couple fraction ones to practice within this.